Hi, this is a presentation of how you can configure your router to use OSPF, and it is a setup of a single area OSPF configuration, and it's a part of my advanced networking course. First, to enable OSPF, you go into config mode and you say router OSPF and then a number. This number is a process ID, and it's something that you can set from I think from 1 to 65,535. So it's just a number that the router will use for the process that is running in the CPU of the router. It's only locally significant. You don't need to have the same number on all of your routers, but there is no problem if you have the same number on all of your routers. So it's just a number. In this case here, it is the number 10. When you have done so, it is important that each router has a router ID. Either you can manually configure it yourself, or it will just be chosen for you. It's important that it has a router ID because it's something that it will use to be a part of the OSPF domain in your network. So you can set it by using the command router ID and then, for instance, 1.1.1.1. Or you can, if you don't do it, well, then the router will set the ID to the highest overall low loopback address. If you have configured 1 or 2, whatever, loopback addresses, then it will choose that address as the router ID. If you haven't set any loopback address, well, then it will take the highest overall active IP address and choose that as their router ID. For instance, will this be used when you want to elect the designated router, the DR, in a multi-access network? It will choose the one with the highest router ID. You can also set a priority. Then it will choose the one with the highest priority. But if you haven't set anything, well, then the default priority will be the same on all of your routers, and it needs to choose one to be the DR and another one to be the BDR, and then it will only look at your IP addresses, and the highest active IP address will be chosen as the router ID. Yeah, and that's it. Or you can set it yourself, as I said. Then you need to indicate which networks do you want to participate in your OSPF, and how would you advertise them. There are two ways of doing it. The first one here, you say network and then the network that you have, and then you use something called the wildcard mask. The wildcard mask is actually the inverse of the subnet mask, so you just flipped a bit. So in this case here, my subnet mask will be 255.255.255.0. Then my wildcard mask, which I use for OSPF, is 0.0.0.255. So you have to flip the bits and invert them to find your wildcard mask. And then area, and then in this case area 0. We are only using one area at this point, so but you need to have the same area in your entire OSPF setup so that all of the routers will be connected to the same area. And here we also have another network, 172.16.3.0, and the wildcard mask is here 0.0.0.3, which is the inverse of 255.255.255.252, because basically what you do is that you subtract 4 times 255 from your subnet mask, and then you will find your wildcard mask. But of course, you have to do a little thinking, and you have to calculate the wildcard mask. And instead of that, you can also just use the interface IP address and a quad 0, 4 times 0, as your wildcard mask, and it will also work because since it knows which interface that we are talking about, it will also automatically know what kind of a subnet mask that you're using on that one. So the other way of doing it, configuring it, is by using the interface address and the quad 0, 4 zeros as the wildcard mask, and still the area and the area number. It's easier, then you don't need to calculate anything. Yep. What you can also do is that you can set some of the interfaces to be passive, which means that it will not send OSPF updates through that interface. Because if I know that on my Ethernet, I only have one OSPF router present, well, then it doesn't have to send updates all the time out to my Ethernet. So then I can set the interface to be passive, and I do that with passive interface and then the interface name. And then it will not send any OSPF updates out of the interface, but it will still announce and tell the other routers in my network that this network exists. Because if I just skip it and do not include it in my network command, it will not tell the rest of the network about the network either. But I want that. I just don't want updates to be sent out on this interface. So that is why I will use a passive interface. Then we have the metric. In the case of OSPF, it is something called a cost. And it will find a cost by taking something called the reference bandwidth and divide it by the interface bandwidth. Because OSPF will look at the bandwidth and figure out the fast or the shortest path between two networks is the one with the fastest bandwidth. So here, I take the reference bandwidth is set to 1 million? No, 100 million bits per second, which is the same as a gigabit. And the problem here is that the reference bandwidth will not be able to see the difference between gigabit Ethernet and 10 gigabit Ethernet, because we will still have, if we divide these, the cost will be 1, and also on fast Ethernet it will also be 1. So it will not see the difference between fast Ethernet, gigabit Ethernet, and 10 gigabit Ethernet, which could be a problem. But then we can see 10 megabit is the cost of 10, serial is a cost of 64, and so on. And it will always, of course, choose the path with the lowest cost. We can change that. And if I want to see the cost, first of all, I can use the command show IP route, and here 65 is the metric. That is the cost for this route. And it's something that it will accumulate. So if I have a 64 plus 1 will give me a 65 in metric, for instance. I can change the order cost reference, so that if I want to change that, so that I will be able to see difference between fast Ethernet and gigabit Ethernet, for instance, I must remember to change it all over my network. I cannot only do it on 1 or 2 routers. I need to change so that we have the order cost reference bandwidth to be the same. But it's no problem in doing that. So I can just use the command order cost reference bandwidth, and then I can change it if I want to do that. I can also change the bandwidth because it will, of course, be a standard bandwidth, especially on serial links. It will just choose the default bandwidth for a serial link. I can use the bandwidth command, and then it will find out what I have changed it to, in this case 64, for 64 kilobits, for instance. I can also change the cost. If I want to manually set the cost instead of the cost to be calculated, I can set the cost here myself. And this is, of course, another way we can manipulate the thing that it doesn't see the difference between fast Ethernet and gigabit Ethernet. We can just set the cost ourselves. But also remember, whenever manually we start doing something, we need to make sure that we are consistent and do it over the entire network. And we can see our neighboring routers by using the command show OSPF neighbor. And we can see here that we have a full adjacency to our neighbors. We can see the date time, we can see the IP address, we can see which serial interface, and we can also see that the router ID of our neighbors. Yeah, that's the basic setup of OSPF.